We're going to learn in this presentation how to find a confidence interval for the population mean when sigma, the population standard deviation, is unknown. The level of confidence, remember, is the probability that the interval estimate is going to contain that population mean. And the assumption is that we're going to do that estimating process a large number of times. Since we do not know the value for sigma, the population standard deviation, we must use a t-distribution for this confidence interval. So the level of confidence then is going to be the area under the standard normal curve between the critical values negative t and positive t. Now let's learn how to determine those values for t. The problem this time is that we want to find the average earnings per share, EPS, for 10 randomly selected stocks on the NASDAQ exchange. And we find that the average, the mean of that sample of 10 stocks is 1.96, and the standard deviation for that sample is 0.395. Now that's S. Remember, it's not sigma. We don't know the population standard deviation. This time we're going to use a 99% confidence interval, and we want to be able to guarantee that the mean for the population will be in the interval that we come up with. So we're given this time that S, sample standard deviation, is 0.395. The number in our sample is 10. The mean of our sample is 1.96. And in order to use the t-distribution, we have to use this little chart over here, which specifies degrees of freedom. And for the particular degree of freedom for our problem, then we can pull the value for t out of the table. The degrees of freedom, by definition, are going to be equal to always to n minus 1. So if we have 10 in our sample, the degrees of freedom then will be 9. So we'll just go down that column and find 9. I have it circled there, and the value for t then is 3.25. Okay, and therefore we're looking at negative 3.25 and positive 3.25 as the t values for our boundaries. And notice this time our alpha is equal to 0.01 because we're working with a 99% confidence interval. And then in each of those tails, we will find 0.005, alpha over 2. That's the area in the tails. Okay, to find the error now, we're going to use the t value for alpha over 2. That was the 0.005, and you can see that at the top of the second column. N minus 1, which is 9, so we're pulling that value 3.25 out of the table, and we're going to multiply that times our S, the sample standard deviation, divided by the square root of n, square root of 10. If you compute that out, you're going to get 0.4059574. And I think I just kept that large value. The confidence interval, remember, is going to be plus or minus. It's going to be the mean of our sample, 1.96, plus the error on the right boundary and minus the error on the left boundary. So the confidence interval, this time it's 3 decimal place accuracy, 1.554 is less than the population mean, which is less than 2.366. So we are 99% confident that the population mean, mu, is between those two values. So it's very similar to the calculation that we did for sigma known. The only difference is you're using a t table instead of a z table. Using Excel again. And this time the function that we use is confidence.t. Remember, it was confidence.norm if you know the value for sigma, confidence.t if you do not know the value for sigma. And I'm going to put that formula, which requires, again, 3 parameters. Alpha this time is 0.01 because we're 99% confidence. S, the sample standard deviation, is 0.395, and N, the number in our sample, is 10. And the value that's returned is 0.405937, and that will give us the same two endpoints for the confidence interval.